Hello and welcome everyone to the another video on time series modeling. Now in this video we will be learning about what is the difference between prediction and forecasting. So I know it sounds familiar and similar, but there is a huge difference in between them. Okay, so let's understand what is the difference, and then we will be also discussing about what are the scope for prediction and forecasting. Okay, so first of all, let's understand the difference. So prediction refer to an act of estimating or guessing what might happen in future based on available information or data. So it's a broad term that can encompass a wide range of future event outcome or scenarios. Prediction can involve short term or long term event, and are not always bound by a specific time horizon, which means that you know prediction can be done for next month, 6 months from current time. It's not like that. It can have any specific time horizon. It's not like it's not restricted by any uh, you know time horizon basically. So various techniques such as statistical model, machine learning algorithm, expert judgment, or qualitative analysis can be used for prediction, while forecasting is a subset of prediction. So forecasting is like a specific type of prediction that deal with estimating future events or outcome within a defined time frame, and usually involves sequential time period. So it's about systematically anticipating or predicting value or event over time, often using time series data. So forecasting is tied to a particular time horizon and involve predicting multiple future data point in a sequence. So particular time horizon means that you will be either forecasting for next 3 months, 4 months, 5 months. You will be forecasting for next day, or next month, next year, or next 6 months, like that. So it is bound by a time horizon, but prediction was not bound by any specific time horizon. So that's the main difference in between them. Then specialized methodologies like time series analysis, statistical model tailored for time dependence data, economic trend model, or other techniques that account for temporal pattern are commonly used in forecasting. Now let's understand the scope for these two. Okay, so first is, let's understand the prediction part. So scope will be prediction involve estimating or forecast, foreseeing what might occur in the future based on available information or data. So it's a general term that encompasses a wide range of future event or outcome. Time frame for this prediction can be, prediction can refer to a short term or long term event that are not necessarily bound by a specific time horizon, and they can involve immediate future event or extend far in into the future, like more than 2 years, 3 years, 4 years, like that. Okay, so methodology, what all methodology we have for prediction. So prediction can be made using diverse techniques such as statistical model, for example linear regression, classification model, etc. Okay, then we have machine learning algorithm, deep learning algorithms like neural network, decision tree, random forest, etc. Okay, then in expert judgment, so it's basically doing something based on experience or domain knowledge. Okay, so for example, you are neurologist, and you are experienced in that field, so that time you can use the expert judgment for doing some prediction. Then we have qualitative analysis, where opinion and subject reasoning comes into the picture, where some type of analysis you do, qualitative analysis. Okay, and based on the reasoning you give the prediction. So for example, short term prediction might involve guessing whether it will rain tomorrow based on current weather pattern. Then in long term prediction, it could be estimating a person future income based on education, experience, and career trajectory. Now let's understand the forecasting scope and time frame as well as methodology. So for forecasting, it's specifically pertain to predicting future event or outcome over a future defined time horizon. Okay, often focusing on sequential time period and understanding the trends. So what will be time frame? So forecasting is linked to a specific time horizon, and usually involves predicting multiple future data point in a sequence. So it's about anticipating values or event in a structured manner over time. So what methodology we have? So in forecasting, it's predominantly relies on time series analysis, statistical models specially designed for time dependent data, econometric models, or other specialized techniques that account for temporal pattern and relationship. So for example, forecasting might entail predicting next month sales figure for a company based on historical sales data, market trend, and seasonal pattern. Predicting the stock price for the next 30 days based on historical price movement involves a forecasting task due to its sequential nature and time dependent. So in a sense, forecasting is a subset of prediction that focuses on estimating future values or event over a specified time horizon, often using time series data and specialized technique designed to handle sequential time dependent pattern. Okay, so lastly, I would like to add one point, that is, while all forecasting involves prediction, not all prediction fall into the category of forecasting. So forecasting is more focused and specialized, particularly in handling time dependent data, understanding sequential pattern, and making structured prediction over a specified time horizon. So it's more targeted approach to make prediction within the context of time series analysis and temporal relationship. So next we have some assumption that we should be taking care all the time when we are doing time series modeling. Okay, so let's understand all of them. So first is stationarity. So we have two different type of stationarity, strict and weak. So let's understand the strict first. So for a time series to be strict stationary, the joint probability distribution of any set of variable within the time series should be invariant over time. This means that statistical property like mean, variance, covariance remain constant across all time period, whereas weak stationarity tells that this is a less strict form of stationarity which requires the mean, variance, and autovariance to be constant over time, but might allow for changes in higher moment or pattern in the data. So stationarity is crucial because many time series model assume a constant mean and variance over time. Techniques like differencing, which is transforming the data by subtracting the previous observation from the current one, are often used to induce stationarity in non-stationarity data. Okay, so we will be doing some task on this as well, so we'll see that later on, but let's complete the assumption first, the understanding part. Then we have independence of observation. So the observation in a time series should ideally be independent of each other, and this assumption ensures that the value of any given point in the time does not depend or influence the value at other point, which guarantees that each observation provide unique information, or you can say not depend on the previous observation. Okay, then we have constant variation. Okay, so what does that mean? So basically the sorry which refers to the stability of variance over time. So in time series modeling, it's important that the spread of the data point around mean remain constant throughout the time series. So this condition is necessary in linear regression based model. Okay, next we have is no autocorrelation of residuals. So autocorrelation refer to the correlation between time series and a lagged version of itself. So lagged version is like a previous row of current row. Okay, so in modeling, the residual, which is the difference between observed and the predicted value, should not display any systematic pattern when plotted against their own lagged values. So autocorrelation implies that the model hasn't captured all the information present in the data. Then we have normality of residuals, which basically tells, while it's desirable for residual to follow a normal distribution, or you can say bell-shaped curve, it's not always strict necessarily. Okay, so however, normality help in making reliable statistical inferences. Deviation from normality might affect the accuracy of confidence interval or hypothesis testing based on the model. Last we have is model adequacy and validity. So this assumption pertain to select the most appropriate model that adequately represent the structure of the time series data, and it involves choosing the right model that fit the data well, capture relevant pattern or trend, and provide reliable predictions. So it's important to note that while these assumptions are desirable for many time series model, not all models strictly require all of these conditions to be met. For instance, machine learning model like neural network might be more flexible and robust to deviation from the assumption compared to the traditional, statistical models like ARIMA. So adjusting uh, and consideration are often made based on the characteristics of data and the model being used. So I mean, we will be seeing that later on, but these are the assumptions we need to follow while we are doing time series modeling. Okay, so see you guys in the next series. So that's all for today. Thank you guys.